Hi, my name is Brian Pentland, and I want to talk to you about visualizing clinical trajectories with ThreadNet. This is some work that's supported by the National Science Foundation, and I'm really excited about the possibilities. So let me kind of run through this quickly. ThreadNet is a package written in R. It's a software package that you can download from GitHub. It's an open source thing. And it's a tool for visualizing patterns in processual phenomena, any kind of thing where you've got timestamp data. So you can read in the data, choose your point of view on the data by defining what you want to see as threads and events, and then use that to visualize and compare. And you can download this from the website there. So the cool thing about ThreadNet is that it weaves threads, which we'll talk about more in a minute, into networks. And in particular, it does this, it weaves, you can also think of it as weaving stories into narrative networks. So a narrative network is this idea that Martha Feldman and I introduced a few years ago. In a narrative network, unlike a social network, the nodes are categories of action, and the edges represent sequential relations between those actions. Right? And the cool thing is narrative networks are a convenient way to summarize patterns of action and also the possibilities for performing those patterns. So it packs a lot of information into a very simple representation. ThreadNet has other kinds of visualizations as well, but what I want to talk to you today is about this idea of networks and trajectories of networks. So, what do I mean by trajectory? Well, a trajectory for me is a change in an action pattern over time. Now, within, say, for example, a dermatology clinic, you might think of, well, there's the trajectory of a patient as they move through the process of getting, brought to a room, take the vital signs, all that stuff. So a single narrative like that, I would refer to as a path or a thread. But you can create a network of threads, and I'd refer to that as a pattern. So the trajectory is a change in that network over time. So I'm going to show you some examples. We're going to start with a simulation thing. So this is based on a paper that we did a few years ago. On the right-hand side there, you see a series of performances or threads, right? That's like 1, 3, 12, 11. Those are just sort of coded sequences that represent stuff that happens. On the left-hand side, you see the pattern or the network. So the pattern, you can think of this as generating performances. So it's performing the performances. And then those performances will themselves tend to get retained back into the pattern over time. So that's this sort of new language here for this is performing and patterning. So you can look at the trajectory of the network structure over time. And those of you that are familiar with the dynamics of social networks have seen things like this. At time one, you might start with just a simple, straight, happy path. And over time, through variation, the network gets more complex. Right? And then there'll be, so in this particular simulation, we were interested in tracking complexity of these network structures over time. And what's interesting is that you can get, just through endogenous change, dramatic changes in complexity. It's really quite remarkable. So if you want to play around with this yourself, you can go to the website here. It's routines.broad.msu.edu, and there's a simulation there. So before I run it, I just want to call your attention. So up in the upper right-hand side where it says network graph, you see a sequence of nodes, and you can kind of go around the clock there, 1, 2, 3, 4, 5. What that's showing is that we're going to start with a routine that's just a straight shot, always the same. So if you look down on the lower left, you'll see the performances, 1, 2, 3, 4, 5, 6, 7, 8, that's representation of the graph. And if you look at the history matrix, you'll see the same thing. You get that diagonal of, always with a 100% chance, 1 leads to 2, 2 leads to 3, 3 leads to 4. So if you go to the website, you can play around with it, slide the sliders back and forth. It's a lot of fun. So I want to just let it run now. And while it's running, I want to call your attention to a couple things. So in this simulation, whenever the history matrix goes red, it means it's adding network paths. So if you look at the network, you'll see a lot of new edges are being formed. When the history matrix goes blue, it means it's reducing, like it's losing network paths. Right, so we're going to run this for about 90 some steps here. And if you look at those performances, now we have, it's not just 1, 2, 3, 4, 5, 6, 7, 8. There's a whole bunch of different things that are happening, right? And so this is a simple model to help people gain some intuition about this idea of how the trajectory could be changing over time. So let's look at a real example. So this is from clinical routines in dermatology clinic. My co-PIs on this are Julie Ryan and Alice Pentland, who's actually my older sister at the University of Rochester Medical Center, and Ken Frank, who's a network methodology guy here at Michigan State University. So we're looking at clinical processes. The data I'm going to show you are from electronic medical records, the audit trail. So this is really not medical research, it's organizational research. We're sort of just looking at how people are doing the work. We're also going to be collecting similar data through interviews. The site currently is dermatology, which is like the simplest one we could do. Plus my sister's chair of the dermatology department, so that made it good. And then we're going to look at more complex settings like orthopedics and oncology. And the question we're interested in is what drives the complexity of these clinical processes. So the electronic medical records give a really detailed trace. So what I'm going to show you is dermatology clinics. We have 2 years of data in one clinic. So that's about 35,000 patient visits and 1.2 million records like these ones here. And if you can see this, you'll notice the timestamps, every few seconds something happens. So the first ones that are shaded there are the patient arrives and is checking in at the front desk with the administrative technician. And then they go to the room and the nurse, licensed nurse, does things like checking the vital signs, enters the chief complaint, and so forth. So this is the type of data that we're using. And I've showed you an image like this before. You can see, so these colored lines that are being added are the threads. Each patient visit is a thread, and each day in the clinic has about 20 to 30 patient visits, right? So for each day in the clinic, you take a group of those threads and weave them into a network. Looks like that. It's very, networky. And then you can create a trajectory of networks. So in this case, this is 498 working days in one dermatology clinic. Each point is 1 day, right? So the x-axis here is 498 days just in a row. The y-axis is showing how similar 1 day is to the other days. There's sort of a reference point that I use. I can't get into all the details in the amount of time I have, but the idea is that there's a bunch of days at the beginning that are all they're similar to each other but different from the reference, right? And then there's these phases it goes through, and the changes from more to less similar occur roughly on March 15th and November 1st. Not just 1 year, but repeatedly in both years. So it's kind of a mystery. We showed this to the dermatologists, and they had no idea. So it's a fascinating mystery about why this happens. What's interesting is that the clinical complexity also changes over time. So down at the bottom of this, we see that same graph. The upper graph is indicating the complexity metric that goes along with each of those points. And if you group it by month, they're definitely significant. So this is the kind of stuff we're investigating. This is sort of preliminary results that we have just been playing with. I wanted to share it with you, partly because I think it's interesting in itself, but mainly because it gets us into this idea of dynamics of event networks. So social networks are becoming a more dynamic topic. We're looking at how the formation and dissolution of edges in a network change network structure over time. Right? That's how it's conceptualized. But compared to social networks, these action networks, event networks, narrative networks, all that stuff is just completely unexplored territory. Right. So the material I've shown you here today is not something that you would probably see other places. Um, we know that processual phenomena change over time, right? That's kind of a given. And you can see that here in this data. But what we need, I think, is to learn how to see these changes, right? We need to develop theory and conceptual vocabulary to help understand the trajectories of event networks, the dynamics of event networks, and we need to develop visual literacy so when we see something in these graphs, we understand how to interpret it. And this is, basic research. We're, just kind of getting started with it. So to help develop visual literacy, that's what ThreadNet is for. So I would encourage you, if you're interested, you can go to this URL. There's instructions for downloading. It's easy enough to use. No programming is required. The data format is very straightforward. Minimal assumptions about your data. So it's useful for a lot of different types of things, not just medical EMR records. And plus it's free and you can just download it off GitHub and run it. So thank you very much for your time and attention. Hope you enjoyed the show.